Solvents are a very important component of SN1 and SN2 reactions. Although they are not per se in the rate equation for either SN1 or SN2, the solvent has an effect on the transition state energy and so must be considered in how it affects the rate of SN1 and SN2 reactions. Solvents are very important in SN1 reactions because it changes the energy of the transition state and carbocation intermediate energy. The carbocation intermediate has a positive charge on the carbon, and then there's a counter ion. That is charge separation, and that's the ultimate in polarity. Because it's very polar, it needs a polar solvent to stabilize that charge separation. The transition state is directly related to the stability of the carbocation. If you have a stabilized carbocation, then the transition state will be lowered by the stabilization of that carbocation. So then the reaction rate would increase. So let's look at an example. Water is more polar than methanol, so what we find is the increased polarity of water makes an SN1 reaction go faster. So when water is a solvent, SN1 reactions occur more quickly. Protic solvents accelerate SN1 reactions because they can hydrogen bond to the leaving group, and that actually helps the leaving group to leave. Because as the leaving group leaves, you're putting del positive onto the carbon, and that puts a del negative onto the leaving group. If you have a hydrogen bond to the leaving group, that helps reduce the amount of charge on that leaving group and making it more stabilized. So the transition state is lowered by hydrogen bonding to the leaving group. Protic solvents are solvents that have a hydrogen attached to either an oxygen or a nitrogen. So if I look at methanol, which has an alcohol group, I can recognize that it is protic. However, if I see an oxygen or a nitrogen and there's no proton, no hydrogen on that oxygen or nitrogen, it is not going to be a protic solvent and it's not going to help an SN1 reaction. So for an SN1 reaction to go ahead, we almost always use a protic solvent. Solvents are important to SN2 reactions too. When we are running SN2 compounds, we almost always have a negative charge on the nucleophile and a positive charge on a metal counter ion. These are ionic, and in order for those things to go up into solution, because they're so polar, you're going to have a polar solvent to suspend it into solution. Protic is very important versus aprotic. A protic solvent will hydrogen bond to the negative anion, that is the nucleophile. That reduces the nucleophilicity. And so a protic solvent actually ties up the nucleophile, so it's less likely to attack the substrate. However, if you have an aprotic solvent, that can't hydrogen bond to that anion. In fact, it leaves it naked in the solvent, and it makes it more nucleophilic. So when I have an aprotic solvent, DMSO, THF, acetone, HMPA, a lot of them are acronyms, they will increase an SN2 reaction quite a lot. If I have a protic solvent, it slows it down. Down here, you can see here's a nucleophile with a non-bonding pair that makes it either negative or neutral, but that non-bonding pair has a lot of negative charge on it. A protic solvent is going to want to be immersing that hydrogen with a large del positive into that non-bonding pair, therefore deactivating the nucleophile. Aprotic solvents do not hydrogen bond. Here is DMSO. This is the Lewis dot structure for DMSO. You can see that DMSO has a very negative oxygen that will actually coordinate with a positive anion. What does it do to that nucleophile? it actually makes that nucleophile kind of naked and more nucleophilic. So the polar aprotic solvents, not only do they help to solvate the nucleophile, but they pull the cation away from the anion, making it more nucleophilic. So here are some polar protic solvents. These are going to accelerate SN1 reactions. Notice a hydrogen on an oxygen, a hydrogen on an oxygen, hydrogen on an oxygen, hydrogen on a nitrogen. Now, oxygen is more electronegative, so those solvents that have oxygen in them tend to be more polar and accelerate an SN1 reaction better. But all of these would help an SN1 reaction go. Polar aprotic solvents increase the reaction rate of SN2 reactions. The more polar the solvent, the faster the SN2 reaction will be. So DMSO is highly polar. That's the acronym for dimethyl sulfoxide. This is acetonitrile, very polar. DMF is dimethyl formamide. It's very polar, but it is beginning to decrease in polarity. HMPA, hexamethyl phosphoramide, it's very polar. And acetone, all of these solvents can be used to conduct an SN2 reaction in it. However, if you use any of the polar protic solvents, they'll basically make an SN2 reaction very difficult, and it won't go ahead. Aprotic and low polarity solvents will basically inhibit both SN1 or SN2 reactions. What kind of solvents fit this category? Hexane, benzene, toluene, ether, ethyl acetate, dichloromethane. Dichloromethane is a little more polar than the others, but it's still just not polar enough to accelerate an SN2 reaction. And none of these are protic, and a protic solvent is really needed for an SN1 reaction. So which of these reactions would be faster? Well, if I look at the two reactions, this is primary, that is primary. Because it's primary, the reaction must go SN2. So I look at the reaction and I see the only difference between the top and the bottom is the top has DMSO and the bottom has water. So the DMSO favors an SN2 reaction, so the top reaction. Which one of these reactions would be faster? If I look at the top reaction, I see, well, if I look at both of them, I can see it's a tertiary substrate. So the mechanism must be SN1. Since it's SN1, I'm going to need a polar protic solvent to make it fast. Acetone is polar aprotic, methanol is polar protic. The reaction will proceed faster in methanol than in acetone.